Assalamualaikum warahmatullahi wabarakatuh. I am Kevin Cesio Gemilang. I will present to you about my research result with title Churn Analysis using Survival Model and Random Forest Classification for Customer Prediction under the guidance of Professor Dr. Engineer Asep Saifuddin MSc and Mr. Anwar Fitrianto MSc PhD. This is our agenda today: background, data, procedure, result, and the conclusion. I try to explain it clearly in a chapter. Background. This research show up because of general company problem, that is a churn customer. Churn customer has a significant impact on a company. I list at least 5 most significant impact that will make company consider to handle churn customer. First, to reduce company profits due to reduced shopping transaction. Second is to reduce efficiencies the companies to make money. Third is indicate customer bored or didn't like service or product. 4. Return customer are more complicated than acquiring a new customer. And last, make companies confused how to manage customer will churn or not. So, what is churn customer? Before we know that, we should know about definition about loyal customer. Loyal customer are the customer who are willing to do a repeat business transaction with a company or a brand. And the other side is churn customer. IBM defines customer churn as the process of customer replacement that is not limited to the telecommunication market. According to the impact that will arise, the company should handle churn customer. Company needs system and methodology that can assist companies in dealing with customer churn. First, company must define churn customer, and then second, find an important factor, and third is to predict the customer. Goals in this research: first, to determine the customer lifetime value using survival analysis, to implement random forest classification technique to analyze customer churn and identify factors that influence customer churn, and to predict future customer prospect to become loyal customer or churn customer with a simple web app. Okay, this is the methodology section. I will explain about my data, procedure, and definition that I use. This is my data summary. I have this data from a company that sells nutrient boosting, milk, snack, other supplement, etc. My observation are transactional per item that is done by membership customer. So if the customer doesn't sign up to be a member of this company, the transaction will not be recorded. I have 2.2 million transactions from January 2017 to April 2019, and 70 variables that I can use. Analysis procedure. First, transactional data per item. Pre-process the data and clean transactional data. This is the first stage, is to conducting the analysis data collection by understanding the company business interest. And then go to the pre-process for survival analysis, do survival analysis, and look for customer purchase lifetime value. This is the second stage. Third stage, form random forest classification. First step to make a random forest classification is pre-processing of the data, including the reduction of variables, improving data structure, and transaction selection to create a new variable. And then splitting into data train and test, handling imbalanced data with undersampling, tuning hyperparameter random forest, and make random forest, and then look about random forest performance. If random forest performance is good, next step is to determine important feature and make a simple web app. This is the definition that my company used to define customer repurchase lifetime value and churn customer. Repurchase company lifetime defined as the time when 80% of repurchase customer make their second purchase. And not churn customer defined as first, repurchase before repurchase company lifetime. Second, make transaction again before company lifetime. Third, repeat step 2 until the first and the last repurchase company lifetime duration is 1 year. My results start with data summary after pre-processing. I take only the customer who makes the first transaction between January 2017 to March 2018. And then I collect the data for all those customers 1 year after his
first transaction. It contains 1.5 million observations, and I only take 6 variables. List of the variables that I take is explained in the table below.
The application of survival analysis begins with the preparation of survival data. Data transformation was carried out to obtain variables that could be used for survival analysis. Below are the list of variables for survival analysis. These variables will be used in survival analysis to determine the survival function and customer repurchase lifetime value.
This is the result of the survival analysis. Survival function describes the cumulative probability for the customer who doesn't make a second purchase yet at a certain time. For instance, 25% of the customers don't make the second purchase yet after 86 days. Another curve that it can produce by survival analysis is hazard function. An hazard function has described the risk of the customer make his second purchase at a certain time. The risk is not a probability. It can be concluded the behavior of the customer to make their second purchase under 100 days is higher than after 100 days. From survival function, I can get the customer repurchase lifetime value that is 112 days or approximately is 4 months. This customer repurchase lifetime value is used to define churn customer by definition that I mentioned earlier. More clearly, you can see the relation between quantiles and the days below. Random forest. Before in random forest classification, the customer should be labeled and take the transaction that we'll use. So I create this variable to specify them. This variable will be joined with the clean data that I have built earlier with keys, customer ID, and purchase date. The next task is to define hypothesis variable and make them. This process converts transactional data to customer data. I propose 10 new variables that might influence churn customer. Because of my data is unbalanced between churn and not churn, I will balance with the undersampling. I choose to undersampling the data because of the volume of the data is too large if I use other methods. Then I choose the random forest hyperparameter. I use research from Ashiro to define the number of trees and look at the out-of-bag error to select the number of variables randomly sampled. This is the performance of a random forest. The accuracy of test data is enough. Its specificity is higher than sensitivity. This tells about my random forest better to predict not churn customer. After the performance of the random forest is good enough, then look at the variables that influence the determination of the churn customer. I used mean decrease accuracy to see the relative importance of variables. Based on the figure below, it can be seen that the average monthly transaction and average monthly expenditure are the two most important variables. The last part is forming an automatic function that can be used by companies to predict customer churn. This function is in the form of a web app that is made with our Shiny package. Use of these web apps by uploading customer transaction data and then downloading the prediction result that feature has provided below. These web apps contain all the steps of the making a random forest and prediction, and this is the example of the front page to upload the customer prediction customer data. After we upload the data, we can download the prediction in this tab. This is the result of the web apps. We can see the probability of the customer classified to churn or to not churn. Conclusion: 80% of a loyal customer in this retail company have the characteristic to do repurchase on days 121 of their first transaction. Random forest performance is good enough to describe customer churn. The total accuracy of this model is 84.84% with a sensitivity of 82.21% and a sensitivity of 86.69%. Random forest suspect that average transaction and average amount of expenditure are the main factor that differentiate customer churn and not. Random forest also conclude that the use of the automatic and manual channels does not significantly affect customer churn. Suggestion: first, do overfitting tasks and change the value of random forest hyperparameter, add others classification method to compare goodness of the model, and then explore customer churn criteria using survival analysis. For your attention, Assalamualaikum warahmatullahi wabarakatuh.